Hello everybody, welcome into another lesson. So today we are going to talk about hyperbolas where the center of the hyperbola is not at the origin. So here we're going to start out again where the x-axis is the major axis. So the general formula for a hyperbola, if the x-axis is the major axis, is again your x variable comes first, but it's going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. When the center was at 0, 0, h and k were both 0, thus giving you x squared and y squared. Well, this is for, in general, for any center. So your center would be at hk. Now, if your x-axis is your major axis, that means your vertices will be at h plus and minus a, and you'll leave your y-coordinate of k alone. Now, when you go to find your slant asymptotes, because those still come into play, you're going to set your y minus k squared over b squared equal to x minus h squared over a squared. And then you'll eventually solve for y. You'll get y equals plus and minus b over a times the quantity of x minus h plus k. So you'll get two lines that are in slope-intercept form for your slant asymptotes. And then, of course, like before, you'll have foci, or foci, however you pronounce it, where c squared equals a squared plus b squared. You solve for c, and if your x-axis is the major axis, your foci are at h plus and minus c, and you leave your y-coordinate of k alone. So that's if the x-axis is the major axis. Now let's talk about when the y-axis is the major axis. What does that look like? So let's go ahead and do that. Let's deal this time with the y-axis being the major axis. So you'll start out with y minus k squared over a squared minus the x minus h squared over b squared equals 1. So still the right side equals 1, but you have y minus k squared over a squared minus x minus h squared over b squared. Since the y variable comes first, the y-axis is the major axis, meaning that the hyperbola has has y-axis symmetry rather. Well, the center is still at hk. That hasn't changed. Your center is still at hk. Now, let's see here. Your vertices, on the other hand, if your y-axis is your major axis, that means you're going to leave your x-coordinate of h alone, but your y-coordinates will change. You'll take that k plus and minus a. Those will be your vertices. Now, let's go ahead and find our asymptotes. You're going to have two slant asymptotes again. So take your y minus k squared over a squared, set that equal to x minus h squared over b squared. So then you'll get y minus k squared equals a squared over b squared times x minus h squared, which would give you y minus k equals plus and minus a over b times x minus h, which would give you y equals plus and minus a over b times the quantity of x minus h plus that k. Those would be your two slant asymptotes, y equals plus and minus a over b times the quantity of x minus h plus k. And then your foci, well, again, c squared equals a squared plus b squared, but if your y-axis is your major axis, you'll leave your x-coordinate of x alone, so you'll have the coordinate h, then k plus and minus c for the coordinates of your foci. So those are everything to know in general if you have some center of a hyperbola that's anything other than the origin. So let's go ahead and get started with some examples here. All right, so we have here x plus 1 squared all over 4 minus y minus 2 squared all over 1 equals 1. So we have x plus 1 squared over 4 minus y minus 2 squared over 1 equals 1. So definitely the equation of a hyperbola. Well, first let's determine which axis is the major axis. The x variable comes first, so the x-axis is your major axis, which means the hyperbola will have x-axis symmetry. Alright, next let's determine what the center is. So to get the x-coordinate, set that x plus 1 equal to 0, you would get x equals negative 1. Set that y minus 2 equal to 0, you would get the y-coordinate equals positive 2. So your center's at negative 1, positive 2. So that's going to be right here. There's the center for this hyperbola at negative 1, 2. Now, next thing I suggest is we find our asymptotes. So the asymptotes, of course, are always going to travel through the center. Now, take that y minus 2 squared, set that equal to your x plus 1 squared all over 4. You get y minus 2 equals plus and minus 1/4 times x plus 1. So if y minus 2 equals positive 1/4, you would have 1/4 x plus 1/4, which would give you y equals 1/4 x plus 9/4. That'll be one of your asymptotes. Y equals 1/4 x plus 1/4. So let's plot that. So if x is 0, you'll end up literally having 9/4. So that'd be 2 1/4. If x is negative 1, you would be down at 2 for y. So I think we could see which way this is going to go here for our graph. And again, these asymptotes, they help guide the shape of your curve. Now, if we take y minus 2 equals negative 1/4 times x minus 1/4, we would end up getting y equals negative 1/4 x plus 7/4. So there's a different asymptote. Y equals negative 1/4 x plus 7/4 is your second one. So when x is 0, you would get 7/4, which would be a little south of 2. Now, when x is negative 1, you would end up getting 2. When x is negative 2, you would end up getting you end up getting 9/4. So here's roughly what that asymptote is going to look like. Whoa, that's a way big jump there. I don't want to jump that big. So there's your asymptotes graph now. Now that we've ascertained that, we have our asymptotes. Let me write those up here, okay? Since we've seen the work to get there, let's go ahead and condense this a bit. So we'll get y equals 1/4 x plus 9/4, and y equals negative 1/4 x plus 7/4. Those are your two slant asymptotes. Once we've drawn those, the next thing we need to do is get our vertices. Well, x-axis is the major axis, okay? So a squared equals 4. That means a equals plus and minus 2. So your vertices, since the x-axis is major, take negative 1 minus 2. You'll have a coordinate of negative 3, 2. So let's plot negative 3, 2 is right about there. And then you're also going to have, if you take negative 1 plus 2, you'll have a coordinate of positive 1, 2 for your second vertice. So right about there. And right now we actually have sufficient points to graph this hyperbola. It's a very tight squeeze here based on the asymptotes. Very tight squeeze. One more thing though, we got to find the foci, which would be c squared equals a squared plus b squared, which means it's going to equal 4 plus 1, which equals 5. So c would equal plus and minus the square root of 5. So since the x-axis is the major axis, you're going to end up having your foci at negative 1 plus and minus the square root of 5 with your y coordinate of 2. So that's going to be a little more than negative 3 here for your focus, and a little more than positive 3, or a little more than 1 here for your focus on this side. So there's your hyperbola with the center at negative 1, 2, and your asymptotes and your vertices at negative 3, 2, and 1, 2. So that's how that shifted. Alright, let's do a y-axis one where the y-axis is major. So let's say we have y plus 6 squared minus x minus 2 squared equals 1. Notice neither of these have a denominator. Well, they actually do. They both have a denominator of 1. Now, had this been an ellipse and it was plus instead of minus, that would actually become a circle with a radius of 1. If they both have the same denominator, especially 1, if it were an ellipse, then it would actually become a circle. So that's how circles and ellipses relate. But in hyperbolas, you can have the same denominators and get away with that. So y plus 6 quantity squared minus x minus 2 quantity squared equals 1. Well, which variable comes first? Definitely your y, right? So that means the y-axis is the major axis. So that means this parabola, this hyperbola rather, will be symmetric with the y-axis. Next, find your center. So to find your x-coordinate, take that x minus 2, set it equal to 0. You would get x equals 2. And then take that y plus 6, set it equal to 0. You get your y-coordinate at negative 6. So the center is located at 2, negative 6. So there's your center right there at 2, negative 6 for this hyperbola. Okay. Now, what I'm going to suggest is we find our asymptotes. So we're going to have two slant asymptotes again. So take that y plus 6 squared set that equal to the x minus 2 squared. Having no denominator makes this a lot easier. That means y plus 6 equals both plus and minus the quantity of x minus 2. So let's start with y plus 6 equals x minus 2. You would get y equals x minus 8 for one of your asymptotes. So y equals x minus 8 is one of your asymptotes. So at 0 you would get negative 8, 1 you would get negative 7, 2 you get negative 6. So here's roughly what your asymptotes are all going to look like. So there's your y equals x minus 8 asymptote. Now, your other asymptote would be when y plus 6 equals negative x plus 2. So that would give you that y equals negative x minus 4 for your second asymptote. So at 0 you would get negative 4. At 1 you would get negative 5. Let's see, that ain't right. 0, yeah, 1 you get negative 5. Let's see, 1, 2, 3, 4. So negative 4, negative 5, negative 6. There we go. Okay. I got it now. I was looking at it wrong. So there's your asymptotes. Now, let's write these up here so we don't run out of room. I think we've seen the work to get there plenty. So your two slant asymptotes are y equals x minus 8, as well as y equals negative x minus 4. Those are your two slant asymptotes. And they do travel through the center. Now, next thing we got to do is find our vertices. Well, if the y-axis is major, that means your a is 1, right? So a squared equals 1. That means that a equals plus and minus 1. So you're going to take plus and minus 1, add that to your y-coordinate of the center of negative 6. So your vertices will be at 2, negative 7, and then again at 2, negative 5. Those are your vertices. So let's go ahead and plot those. 2, negative 7, and 2, negative 5. So now we can go ahead and graph this hyperbola. And then last but not least, let's go ahead and find our foci. So c squared equals a squared plus b squared, which then means that that equals 1 plus 1, which equals 2. So c equals plus and minus the square root of 2. So your foci are going to be at your x-coordinate of 2 still, but your y-coordinate of negative 6, both plus and minus the square root of 2. Those are your foci. So that's going to be below negative 7 a little bit here, a little bit below 2, negative 7, and a little bit above 2, negative 5. Those are your two foci. So now we have completely graphed this hyperbola with the center at 2, negative 6, and your slant asymptotes, your vertices at 2, negative 7, 2, negative 5, and then your foci. Now let's do a couple special equations here. Let's say you were given 9x squared minus y squared minus 36x minus 6y plus 18 equals 0. So you have 9x squared minus y squared minus 36x minus 6y plus 18 equals 0. Well, this is definitely the equation of a hyperbola, but we need to completely factor this. We're going to have to do it like we did with ellipses and complete the square. So next thing you want to do, get your x and y terms together. This would be 9x squared minus 36x minus y squared minus 6y, and then get rid of that 18 from the left. That'll be equal to negative 18 on the right. Now, for your x and y terms, factor out the common coefficient. So for your x terms, you can factor out a 9, right? So 9 times the quantity of x squared minus 4x. And then for your y terms, you can factor out a negative 1, so that'll be minus y squared plus 6y equals negative 18. Now we're going to have to complete the square and figure this out. So 9 times the quantity, we have x squared minus 4x. So to complete the square, take half of that negative 4. That's negative 2. Square that, you'll get plus 4. Minus your second one. So take y squared plus 6y. Half of 6 is 3. Square that, you get 9. So you'll get y squared plus 6y plus 9. All that equals negative 18. So, but to complete the square, you got to do all this to the other side. So take 9 times 4, add it to your second side. That would become plus 36. Now, that plus 9, we actually have to multiply that by negative 1, so this will be minus 9. So this is all going to turn into 9 times the quantity of x minus 2 squared minus y plus 3 squared is equal to negative 18 plus 36 is positive 18 minus 9 is 9. We're almost there. We have 9 times x minus 2 squared minus y plus 3 squared equals 9. Well, the right-hand side needs to equal 1. It currently equals 9. So we have to go through and divide everything by 9. So if we do that, you'll end up getting x minus 2 squared minus the quantity of y plus 3 squared divided by 9 equals 1. So now we have a form of the hyperbola we can work with. X minus 2 squared minus y plus 3 quantity squared over 9 equals 1. Okay. So there is that. Now, what we have to do here is we're going to identify the center and all that, but first let me move all this up here. Since we have completely factored this and completed the square, let's erase some of this so I don't run out of room on the board. Since we got the equation we desire, the form of it we desire. So let me rewrite this here as x minus 2 squared minus the quantity of y plus 3 squared over 9 equals 1. There we go. Now we can go through and identify everything. So first, which axis is the major axis? Well, the x variable comes first, so this time the x-axis is the major axis. So that means this hyperbola will have x-axis symmetry. So we've identified the major axis. Now what's the center? So to get the x-coordinate, set that x minus 2 equal to 0. You would get the x-coordinate as 2. To get the y-coordinate, set that y plus 3 equal to 0. You get the y-coordinate to be negative 3. So your center is at 2, negative 3, which would be right here. So there is your center at 2, -3. All right, now, here's what else we're going to do. We're going to find the asymptotes now. So to find your asymptotes, set your y plus 3 squared all over 9 equal to that x minus 2 squared, which would mean y plus 3 squared equals 9 times x minus 2 squared. So y plus 3 would equal plus and minus 3 times x minus 2. We'll start there. So if we deal with the plus 3 times x minus 2, we'll have y plus 3 equals 3x minus 6, which would give you that y equals 3x minus 9 as one of your asymptotes. So we have 3x minus 9 for one of our slant asymptotes. So at 0, we're all the way down to -9. 1, we're at 8, 7, 6. 1, we're at -6. 2, we're at, let's see, so that'd be 6 minus 3. We're at -3. 3, we're at 0. Okay, so I think we can sufficiently plot these asymptotes now. I'm satisfied with that. So there's sufficient points to plot our asymptotes. Now, to find our second asymptote, we'll take y plus 3. Well, let's go on -3 times x minus 2. So y plus 3 equals -3x plus 6, which would mean y equals -3x plus 3. That's our second asymptote. So at 0, we would get 3. At 1, we would get 0. At 2, we would get -3. And then at 3, we would get -6. All right, so there's our asymptotes. We found our asymptotes, so let's just write them up here. We've seen the work we got to do now to get said asymptotes. So we'll have y equals 3x minus 9 as well as y equals -3x plus 3 for our two slant asymptotes. All right. Next, we need to find our vertices. So if the x-axis is the major axis, that means our a squared equals 1, which means a equals plus and minus 1. So since the x-axis is major, our two vertices will have 2 minus 1, so you would have 1 -3, and then you would have 2 plus 1, you would also get 3 -3. Those would be your two vertices. So you would have 1 -3 and then 3 -3. And right now we have sufficient points to draw the shape of this hyperbola. So let's go ahead and do that here. And one more thing we got to get's the focus. So c squared equals a squared plus b squared, which would end up equaling 1 plus 9, which equals 10. So c squared equals 10, c equals plus and minus the square root of 10. So your foci are going to be at the coordinates 2 plus and minus square root of 10, and then a y coordinate of -3. So let's figure out where the foci are going to be. I know square root of 10's a little more than 3. Let's see, negative square root of 10 is -3.16 roughly, plus 2, that put us at -1.16 roughly. So that one focus will be right here. And then let's do the other focus. That'd be about 5.16. So here's the other focus right about there with these hyperbolas. So we have completely graphed this hyperbola with the center located at 2, -3, your various slant asymptotes, your vertices at 1, -3, 3, -3, and then your foci. One more graphing one, and then we're going to do some more find the equation type exercises. All right. What if we have, let's see, 9y squared minus 4x squared plus 8x plus 18y plus 41 equals 0. So we have 9y squared minus 4x squared plus 8x plus 18y plus 41 equals 0. Okay, well, this is the equation of a hyperbola, but, however, we're going to have to go through completing the square again to get it into a form that we can actually use to graph this. So let's go ahead and start making those transformations. Start by getting your variables together. So this would become 9y squared plus 18y minus 4x squared plus 8x equals, now get rid of that 41 out of the left side, this would equal -41. So now what you want to do is go through on each of your variables, factor out the common coefficient. So on the y's, you could factor out a common 9. You'll get 9 times y squared plus 2y. And then on your x's, you could factor out a common -4. So minus 4 times x squared minus 2x equals -41. Now here's where we go through and complete the square. So on your y's, you'll have 9 times y squared plus 2y. This would be plus 1 minus 4 times x squared minus 2x plus 1 equals -41. Now, take your 9 times 1, you'll end up getting plus 9. And then you end up taking -4 times 1, that'll end up being -4. Did I look at this right? Yeah, I sure did. Alright, so what you end up getting then is 9 times y plus 1 squared minus 4 times x minus 1 squared equals, so what's -41 plus 9? That's -32 minus 4 equals -36. Well, you need both sides to equal +1. So you need the right side to equal +1, so you gotta divide both sides by -36. If you do that, you'll end up getting the negative of y plus 1 squared all over 4 plus x minus 1 squared all over 9 equals 1. So it looked really like we were going to make the y-axis the major axis, but in reality, that negative sign on the right flipped it around to where the x-axis became the major axis. So x minus 1 squared all over 9 minus y plus 1 squared all over 4 equals 1. So really the x-axis is the major axis. Just because they start out with a certain variable being in the first position does not mean that's how it's going to end. So very important lesson learned there. So this would turn into x minus 1 squared over 9 minus y plus 1 squared over 4 equals 1. So once again, the x-axis is the major axis. So now we can go ahead and get all the information we need to graph this bad boy. Alright, so we just stated that the x-axis is the major axis, so that means it's going to have x-axis symmetry. So what's the center? X minus 1 equals 0 will give you the x coordinate of 1, and then y plus 1 equals 0, the y coordinate would equal negative 1. So your center is located at 1, negative 1, so that's right there. There's your center for this hyperbola. Next thing we should do is find the asymptotes. So set your y plus 1 squared all over 4 equal to your x minus 1 squared all over 9. Alright, so you'll have y plus 1 squared equals 4/9 times x minus 1 squared, which would end up then giving you y plus 1 equals plus and minus 2/3 times x minus 1. So let's start there. That's the form our two asymptotes are going to take. Let's operate on y plus 1 equals 2/3 x minus 2/3. So that we'll do the positive 2/3 first. You get y equals 2/3 x minus 5/3 as your first asymptote. So y equals 2/3 x minus 5/3. Alright, so let's go ahead and plot this. At 0, you would get negative 2 and 2/3. 1, you get negative 1. 2, so you get 4/3 minus 5/3. That'd be positive 1/3. So it's going to look roughly like this for your first asymptote. So there's your first asymptote. Okay. Let's write that up here so I don't lose track of where I am and run out of room. So y equals 2/3 x minus 5/3 for your first slant asymptote. Now, let's go ahead and operate under this time we're doing with the negative 2/3 x. So that means y plus 1 would equal negative 2/3 x plus 2/3. So you would end up then getting that y equals negative 2/3 x minus 1/3 for your second asymptote. So y equals negative 2/3 x minus 1/3 for your second asymptote. So at 0, you get negative 1/3. At 1, you get negative 1. At 2, you get negative 2 and 2/3. Do you? Yeah, negative 4/3 minus 5/3. Yeah, negative 2 and 2/3. So one is negative 1. 2, negative 4/3. Yeah, negative 5/3. So that would be negative 1 and 2/3 rather. Excuse me. No wonder it didn't look right. So there's my second asymptote being plotted right now as we speak. And there's both my asymptotes. All right. Now that we've got the asymptotes in the center plotted, let's find the vertices. So the x-axis is major. That means a squared equals 9, which has to mean that a equals plus and minus 3. So the x-axis is major. First, start with your center at 1, subtract 3. You'll end up getting -2, -1 as a vertice. And then if you add 3 to 1, you'll end up getting 4, -1 as a vertice. So here is -2, -1. And then here is 4, 1. Those are both your vertices. Now you have enough to go ahead and draw this hyperbola. And then please don't forget your foci. So c squared equals a squared plus b squared, which would equal 9 plus 4, which would equal 13. So c equals plus and minus the square root of 13. So your foci, since the x-axis is major, you'll take 1 plus and minus the square root of 13 and a y-coordinate of -1. So let's find those coordinates of the foci. Alright, so let's see. -2.61 for, that'd be one focus. And then we have plus the square root of 13. That'd be about 4.61, so that'd be about right there. So there's your two foci graphed with this. So here's your hyperbola with center at 1, -1, vertices at -2, -1, 4, -1, with your foci and your slant asymptotes. Now, we're going to be given certain characteristics of these hyperbolas, and we got to find the equation again. Alright, so the vertices are going to be at 2, 0, as well as 6, 0 for this hyperbola. The foci are located at 0, 0 and 8, 0. So your vertices are located at 2, 0, 6, 0. Your foci are located at 0, 0, 8, 0. Well, what is true with vertices or foci? The center is halfway between them, right? So halfway between 2 and 6 is 4. And you don't see any changes in your y-coordinates, you just see them in the x. So for sure your center is going to be at 4, 0. Having said that, you see changes in your x-coordinates, right, but not your y. That means the x-axis is your major axis. So the equation is going to start out by taking the form of x minus 4 squared over some number minus just y squared, since the y-coordinate's 0, equals 1. All right? Now, okay. If your center is at 4, and then on either side you have a change of 2 units to get to your vertices, that means your a equals 2, which means a squared would have to equal 4, right? And if your x-axis is your major axis, well then that 4 has to go below the x minus 4 squared. So there's part of it dealt with. Now, we don't know the length of the minor axis, but we do know the foci are 0, 0, 8, 0. That's a change of 4 in each direction from the center, which means your value of c has to equal 4, so c squared would have to equal 16. And remember, c squared equals a squared plus b squared. So now we can solve for b squared because we could take 16, set that equal to 4 plus b squared, which simply has to mean b squared equals 12. So you'll put that below your y squared. So the equation you should get is x minus 4 squared over 4 minus y squared over 12 equals 1. So that isn't too bad. All right. Now, let's see here. We have vertices at 2, 3, and then again at 2, negative 3. Then we have foci that are located at 2, 5, and then at 2, negative 5. All right. So the vertices are located at 2, 3, 2, negative 3. The foci are at 2, 5, 2, negative 5. Well, notice that your x-coordinate of 2 doesn't change throughout, but your y-coordinates change. That means the y-axis is the major axis. The y-axis is major, okay? Now, we need to figure out the center. Well, definitely clear to see then, because the center is halfway between your two vertices or halfway between your two foci. Either way, you'll get the x-coordinate located at 2 because that doesn't change. But what about your y-coordinate? Well, 0 is halfway between 3 and negative 3, so your center is actually located at 2, 0. But y-axis is your major axis, so this equation is going to take the form of y squared over some number minus the quantity of x minus 2 squared over some number equals 1. Okay, so from the center of 2, 0 to either 2, 3 or 2, negative 3, that's a change of 3, right? So that means a equals 3, which has to mean that a squared equals 9. And the y-axis is the major axis, so that 9 would go below the y squared. Now, we don't know b squared, or the length of the minor axis, but we do know the c length, because from 2, 0 to either 2, 5 or 2, negative 5, it's a length of 5 units. So c would equal 5. That means c squared equals 25. So now we can set up our equation. C squared equals a squared plus b squared. So that means 25 equals 9 plus b squared. So that has to mean then that b squared equals 16, which would have to go below the x minus 2 squared. So the equation you should get would be y squared over 9 minus the quantity of x minus 2 squared over 16 equals 1. I'm going to do a couple more, but they're going to get a little bit harder. But they're very important that we do them, because these type of problems may come up. Now, what am I talking about here? So, vertices. So the vertices are going to be 2, 3, and then 2, negative 3. So the vertices are still there, but the only other thing they give you is it passes through the 0.05. So your vertices of this hyperbola are 2, 3, 2, negative 3, and it passes through the 0.05. That's all they give you. Well, good news is we can determine the center at least, and even the major axis. Because with your vertices, what changes? The y-coordinate changes, but your x-coordinate stays the same. So that means the y-axis is the major axis. We can ascertain that. Now, so what is the center? Well, your x-coordinate doesn't change, so 2 is the x-coordinate of the center. What's the y-coordinate of the center? Well, halfway between 3 and negative 3 is 0, right? So your center is at 2, 0. So if y-axis is the major axis, that means it's going to be y squared over some number minus the quantity of x minus 2 squared over some number equals 1. Well, we do know the length of A. We actually totally do. Because between 2, 0 to either 2, 3 or 2, negative 3, that's a change of 3 units. So A equals 3, which has to mean then that A squared equals 9. So that 9 would go below your y squared. Now, what are we going to do with this part where it passes through the 0.05? What do we do with that? Good question. So, we need to take b squared, put that into this equation. Then here's what you're going to do. You're going to take the point it passes through, 0.5, put those values in. So, what you'll end up getting here is if you put 0 in for y squared, you'll literally just get 0, right? But you'll get negative of, no wait, y is 5. What am I talking about? I'm doing it backwards. Y is 5. So I'll take 5 squared over 9 minus the quantity of 0 minus 2 squared all over b squared equals 1. So that means 25 over 9 minus that negative 2 squared over b squared equals 1. Okay. So what is 1 minus 25 ninths? Well, this just turned into negative 4 over b squared equals negative 16 ninths. Alright, so guess what? We can do properties of proportions. So we can actually use properties of proportions for this. Let me erase this part. So that's going to mean negative 16b squared equals negative 36, which means b squared equals 36 over 16, which if you divide both by 4, you would get 9/4. So b squared equals 9/4. So that's how you would solve something like that if you just get a point it passes through. So the equation you should get would be y squared over 9 minus the quantity of x minus 2 squared over 9/4 equals 1. And I got one more here. All right, this is good. So let's see here. You have the vertices are going to be located at 3, 0, and then 3, 4. Those are your vertices, 3, 0, 3, 4. But this time they give you that the asymptotes are y equals 2/3 x, and then y equals 4 minus 2/3 x. So you're only given the vertices and some asymptotes. Well, that's okay. Let's take a look at this here. So what changes with your vertices? Your x's stay the same. That stays 3, right? But you do see changes in your y coordinates. So that means the y-axis is the major axis. So that's going to help us out here. Now, what is halfway between 3, 0 and 3, 4? If 3 doesn't change but 0 and 4 do, that would give you 3, 2. So the center of this particular hyperbola is located at 3, 2. All right. We even know the a squared, or the a, because to get from 3, 2 to 3, 0 or 3, 2 to 3, 4, that's a change of 2 units. So your a equals 2, which means a squared equals 4. So that means then that your equation is going to take the form, since y-axis is major and your center is at 3, 2, this will take the form of y minus 2 squared over a number minus x minus 3 squared over a number is equal to 1. Well, that a squared, since y is the major axis, that 4 is going to go right below y minus 2 squared. Now, what about b squared? We don't know that yet, right? We don't know that at all. But let's look at our asymptotes here. It's actually quite easy, because if I take, let's see here, so I would have to literally take then y minus 2 squared all over 4 is equal to x minus 3 squared all over b squared. Well, notice here, it's going to end up being an a over b. In this case, that a squared is 4. That means it's an a over b. So a is 4, right? The general form is going to be y equals plus or minus a over b times x, is what that means. So we have 2/3, so that means y is going to equal plus and minus 2/3 over x. Well, if a is 2, that means a squared is 4. So if b is 3, that means b squared is 9. That's all that means. The asymptotes were actually quite helpful. So in the end, you should get 9 below the x minus 3 squared. So the equation you should be looking for is y minus 2 squared over 4 minus x minus 3 squared over 9 equals 1. So that's actually it for graphing conic sections. We have 2 more lessons left in this unit, and that's just the next one's just going to be given equations, identify the conic section, then give all the information about them. And then after that, we'll be solving quadratic systems, which are basically going to be where 2 conic sections intersect. But we aren't going to be graphing again until we get to trigonometry, which is only a couple units away. So I do hope everyone has a great day. Take care.